All right, now we're ready for the last section of this unit on polynomial functions. This is really just a continuation of what we did in 2.3. It's just now there might be some complex numbers in your answer. That's the only difference. We're going to do the same steps, follow the same procedure. We just might use the quadratic formula at the end. So when we get one and it says find the zeros. The first thing we want to do is find possible rational zeros. We covered that in 2.3. So like here, I'm going to abbreviate that, possible rational zeros, PRZs. Remember, for that, we're going to take plus or minus all the factors of the constant. Well, here our constant is 8, so that'd be 1, 2, 4, and 8, divided by all the factors of our leading coefficient, that is 1. So here, you don't have to do much work. It's just those 4, plus or minus 1, 2, 4, and 8. Then you might want to use Descartes' rule of signs. Remember, we count the sign changes. Well, if you look here, we have positive, 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 negative, positive. So that is 1. So that's 1, 2 sign changes. So that means this has 2 or 0 positive real zeros. Then if we do the negative, remember for the negative ones, we have to plug in a negative x. So we're going to plug in a negative x. So the odd ones change because if you take a negative to the fifth power, it becomes negative. Negative to the third power is negative. The even ones stay the same sign because if you take an even and square it, it cancels out. So that stays positive. Here, this is going to be a negative times a negative. That's a positive, and the constant always stays. So we have that. Well, here we only have one sign change, so that's 1 negative real zero. So we do that to give us some numbers to try in synthetic division. So now for synthetic division, we have 1x to the fifth. We're going to put down our coefficients. Be very careful. If one of them's missing, you have to put a 0. So notice there's no x to the fourth here, so I have to put a 0. Then there's 1x cubed. There's 2x squared. There's a negative 12x, and there's an 8. So there's our coefficients. As I mentioned earlier, I always try 1 first. If you add these together and you get 0, then 1 works. Well, if I add these together, 1 plus 1 is 2, plus 2 is 4, plus 8 is 12, plus a negative 12 is 0. So that means 1 works. So I'm going to go ahead and do 1, even though I know it works, because remember, my goal is to narrow this down to 3 terms. So if I do synthetic division with 1, we bring down the 1 all the way down, then we multiply and add. 1 times 1 is 1, plus 0 is 1. 1 times 1 is 1, plus 1 is 2. 2 times 1 is 2, plus 2 is 4. 4 times 1 is 4, plus a negative 12 is negative 8. Negative 8 times 1 is negative 8, plus 8 is 0. So 1 worked just like we knew it would. But now we've gone from 6 coefficients to 5. Remember, we're trying to get to 3. So we want to try to find something else that works. I think I mentioned the other day, or hopefully I did, if one works, don't be afraid to try it again. Like here, let's try 1 again. Let's add up these coefficients. 1 plus 1 is 2, plus 2 is 4, plus 4 is 8, plus a negative 8 is 0. So that means 1 works again. So let's take our leftovers and use 1 again. So bring down the 1. 1 times 1 is 1, plus 1 is 2. 2 times 1 is 2, plus 2 is 4. 4 times 1 is 4, plus 4 is 8. And 8 times 1 is 8, plus a negative 8 is 0. So 1 worked again. Now we're down to 4 numbers. Now also notice here, see how they're all positive? I mentioned upper bound the other day. Whenever they're all positive like this, that means you don't have to try any numbers bigger than 1. Which we kind of knew anyway on this, and because there were 2 or 0 positive real zeros, since we found 1, there's our second one. But if we hadn't known that, This would have also been a nice tip that we don't have to try 2, 4, or 8, because when all of these are positive, when the leftovers are positive, nothing bigger than that number will work. Well, now we know we need a negative real zero here somewhere, so we want to try a negative. You can try anything. Let's say I tried a negative 4. Bring down the 1. 1 times a negative 4 is a negative 4, plus 2 is a negative 2. Negative 2 times negative 4 is 8, plus 4 is 12. 12 times negative 4 is a negative 48, plus 8 is negative 40. So negative 4 didn't have to happen to work. Notice here, see how the signs alternate here? Positive, negative, positive, negative. That means that's a lower bound. Just like this one was an upper bound, that meant we didn't need to try any numbers bigger than that. This one's a lower bound. We don't need to try any numbers smaller than that. So that just means we don't have to try negative 8. Well, that only leaves 2 negative ones left to try, negative 1 and negative 2. So let's try one of those. Let's say we try negative 2. Now, it's a good idea to cross through these ones that didn't work, so I don't use that one. We always go back and use the last one that worked. So I cross that out to make sure I don't look at that one. So we bring down the 1. 1 times a negative 2 is a negative 2, plus 2 is 0. 0 times a negative 2 is 0, plus 4 is 4. 4 times a negative 2 is a negative 8, plus 8 is 0. So negative 2 worked. So there's 3. Now notice in the beginning we said there's 2 or 0 or 1. Well, that's only 3. How is that going to add up to 5? Well, what that means is the other 2 have to be imaginary numbers. They have to be complex numbers. Now remember, once we get down to 3, we're going to put our x's back in. Well, we had x to the 5th, divided by x is x to the 4th, divided by x is x cubed, divided by x is x squared. When you're down to 3, it will always be x squared. So that's 1x squared plus 0x plus 4. So we get that. We put our x's back in, we set that equal to 0 and solve that. Well, if we move the 4 to the other side, we get x squared equals negative 4. If we square root both sides, we get x equals plus or minus the square root of negative 4, which is plus or minus the square root of 4 is 2, and the square root of negative 1 is I, so that's plus or minus 2i. So if they ask you here for the zeros, we would say 1, and since it's worked twice, that has multiplicity 2. We'd say negative 2, and we'd say plus or minus 2i. Notice if you add those together, so that accounts as 2 of them, 3, 4, 5, there's our 5 zeros. Sometimes you might be asked for the factors. If that's the case, just take x minus each one. So if 1 is a 0, that's x minus 1. Since its multiplicity is 2, it's squared. Here, that's x minus a negative 2, that's x plus 2. And here, since we ended up with x squared plus 4, let's leave that as x squared plus 4. Let's not put x plus 2i and x minus 2i. You could, but you're better off listing it as x squared plus 4. So that's finding the zeros. Again, really nothing different than what we did before, except we ended up with an I in our answer. This next part, for the most part, is the same. We did this too. It says, what if I gave you the zeros first and asked you to go backwards and find the polynomial? Well, you'd always take x minus the 0 to find the factors. So here, x minus a negative 1, x minus a negative 1 is x plus 1. Notice it's a 0 twice, so let's just square that. Then we have x, here we have a 3i, that's x minus 3i. Now one other thing, this is a polynomial with real coefficients. Real means no i's. Well, if one of our factors has an I in it, then its conjugate must also be a 0. So if 3i is a 0, its conjugate, which is a negative 3i, is also a 0. So that'd be x minus a negative 3i. So anytime the polynomial has real coefficients, if you're given an I as one of the zeros, its conjugate must also be 1. And here, if you listed that, if you wanted to get the I out of there, you'd have the x plus 1 squared. If we multiplied these two together, first times first would give us x squared. Since these are conjugates, the middle term should cancel. So the outside would be 3ix. The inside 2 would be a negative 3ix, so they cancel. Then last times last is a negative 9I squared. Remember, since I squared is a negative 1, that's a plus 9. So if we listed that without the imaginary numbers and without the complex numbers, it would look like that. This next one's a little bit harder. It adds something else in here. It's similar. They gave us the zeros. So 2 is a 0. That's x minus 2. Here, 1 minus I is a 0. I'm going to list that with brackets and write it out the long one. That's x minus, it's minus all of that, 1 minus I. So if we distributed that, that would be x minus 1 minus a negative I would be plus I. Now, just like the last one, if this has real coefficients and 1 minus I is a 0, its conjugate must also be 0. That'd be 1 plus I. Well, if I took x minus 1 plus I, again, we need to distribute this minus. That'd be x minus 1 minus I. There would be the factors. Now, notice here, they told us also f of 1 equals 3. Well, if this is our function, this is our polynomial, if f of 1 equals 3, that means we're going to put an a out in front of here. Just to see, because they told us this, we might have to add something in here. Now, the easiest thing to do here is you want to substitute a number in there. Hopefully something that gets rid of something. Like if I was doing this one, we know it goes through the point 1, 3. Let's put 1 in for x, and that would put 3 in for y. So right here, so now we have 3 equals a times 1 minus 2 is a negative 1. 1 minus 1 plus I is just I. 1 minus 1 minus I is a negative I. So now it looks like that. Let's see if we multiply I times a negative I, that's a negative I squared. Since I squared is a negative 1, that's a positive 1. So this is negative 1 times positive 1. So that's just a negative a. So that means a has to equal negative 3. So that means our function would be f of x equals a is negative 3 times x minus 2 times x minus 1 plus I times x minus, oops, got carried away there, times x minus 1 minus I. Now again, a lot of times you don't want to leave the I in here. We would have to FOIL these together. The easiest way to do that is put these two together. So I'm going to leave the first two things alone. I can take x minus 1 times x minus 1. Well, if you FOIL that out, x times x is x squared. We get a negative 1x twice, so that's a negative 2x. And then negative 1 times negative 1 is a positive 1. Now here we can take I times I, that's minus I squared. So that's a negative 3, x minus 2. Here, x squared minus 2x. Well, I squared is a negative 1, so that's 1 minus a negative 1, which is 1 plus 1, which is 2. So without i's, it would look like that. Most of the time, that would be the preferred way. So again, when you get this long thing like this, when this first thing matches, multiply just those two together, like you would any multiplying two binomials, and then it's going to be minus I squared at the end. And I think that is it for 2.5.